Yeah, I will now present my work on partially-indirect Bimanual input with gaze, pen, and touch for pen, zoom, and ink interaction. And I conducted this work with Jason Alexander and Hans Gellersen in Lancaster University in UK. And this work is all about pen and touch displays. And what they're really good at is to utilize bimanual interaction. So in the dominant hand, you can use the pen for very precise inputs. And with the non-dominant hand, you can use multi-touch to adjust the canvas with pen and zoom gestures. And in this context, we wanted to revisit the question of zooming. So where should the point of zooming actually occur on the interface? And for this, we explore three different techniques. The first is like the baseline, so the standard method using the center of the two fingers of the pinching hand. Second, we thought about using the pen's position. So why not actually make users zoom into the pen position when they're performing a pinch gesture? And the third way is to use the gaze position of the user. So by using an eye tracker, we can infer where the user is looking at and allow users to zoom into the position they're actually looking at. So these are three different ways of zooming on the display, and each of them have their individual benefits. So using the touch position is kind of the physical, the natural way of doing it, and we're all familiar with it. So this totally makes sense. But we could also do this at the pen position, to zoom into the pen position, and this could be useful because on a pen and touch display, many interactions are centered around the pen, which is held in a dominant hand. And third, the user's gaze position might be interesting because when you're zooming, you're actually interested in knowing where you're zooming at. So you already kind of look at this point. In order to better motivate these, we've built two application examples. So this is a maps application where users can use the pen zooming technique. And here, every time you perform a pinch gesture, you can zoom into the pen position, even if the pen is in hover mode over the screen. And this also combines well with using pen inking actions. So here the user starts drawing a connection from one city to another city, and at the same time the user can perform pinch gestures to zoom into the pen location without actually interfering with the pen. I also want to introduce a bit more the gaze zooming approach. So what we did here is attach an eye tracker at the bottom of the screen. And so we can now infer the user's eye gaze position. And in this example, the little green circle indicates the user's gaze position. And every time the user performs a pinching gesture, the user can zoom into the position they're actually looking at. And this way also combines quite well with the pen inking operations. So here the user can zoom into their region of interest by looking at it, and then use the pen to precisely annotate objects of interest in a medical image. So what we have is three different ways of zooming on the display. So we wanted to better understand how these compare in practice, and performed a user study in a bimanual pen and touch task. And for this, we investigate task completion time as a standard measure of performance, but also more explorative approaches like the zooming offset, how close are users zooming to the ideal zooming point. And then we also look at the spatial use of the modality. So how did users align both of the hands on the screen, and where was the user's visual attention during the interactions? In our study, we had 18 participants, 3 different zooming distances, 15 repetitions per condition, and we used a multiscale pointing task with 2 variations. So what is a multiscale pointing task? This task was proposed by Guillard and Boudoir and Lafont in 2004, and it essentially consists of 3 different steps of zooming. So the user first zooms out of a set of concentric circles until a second target group is found, and then the user zooms into this target group. And we adopted this task to a bimanual pen and touch environment. So in the first task variant, zooming and inking is used in sequence. So the user first performs the navigation using touch, and then uses the pen to encircle 3 different targets. In our second task type, we use zooming and inking in parallel. So what happens here is that the user starts the task by putting the pen down to draw a straight line on the starting point, and then at the same time, while the pen is on the screen, the user performs the navigation using pen and zoom gestures, and then finishes the task by putting the pen to the destination point. So overall, we had 2 different task types, and we investigated 3 different techniques for the zooming. So I want to discuss the results based on 3 different perspectives. So first of all, task completion time as a measure of performance, and then look at the offset of zooming, so how close are users to the ideal point of zoom, and then more exploratively look at how users aligned the modalities spatially. And so these are the results on task completion time, and what we found is that overall users actually performed similar with all the techniques across both of the tasks, which means that the introduction of indirect input into a bimanual interaction context actually has no penalty, so users can still perform kind of similar. The only difference we found was in the sequence task. So here, using the pen zooming approach, users were significantly slower than the touch zooming approach. And the user feedback indicated that this is because of physical effort with this technique. Users said it is tiring to have to use 2 hands at once. This is based on the design of the technique, so you need to use the pen and touch to zoom into positions, while the other techniques only require 1 hand for the zooming approach. However, in the parallel task, we did not find any significant differences. And this is because in this task, both hands were used anyway in the task, so there was no penalty of using 2 hands for the technique. So secondly, we looked at the offset of zooming, and this is about the question, how far offset do you actually zoom from the ideal zooming point of the task? And in this screenshot, you can see that this is an example of the direct touch zooming, and the actual zooming position is in the center of the 2 touches of the pinching hand. And here it is a little bit offset to the actual target position, and we analyzed this offset in our analysis of the study. And what we did is we looked at each zoom in gesture, and we took the average offset value from all the values from start to the end of the gesture. And this led to the following results. So what we found here is that in the sequence task, the gaze zooming approach was actually significantly closer to the ideal point of zooming compared to the other techniques. And in the parallel task, users with the indirect techniques, the gaze zooming and the pen zooming approach, users were significantly closer to the ideal point than with direct touch. Meaning users were most close to the ideal point with the gaze zooming approach, and furthest away actually with the direct touch approach, the standard method of zooming. Why did this happen? Why is there such a disparity between the direct technique and the indirect techniques? And for this we looked at the offset over time. So how does the offset between the ideal point and the actual zooming point change during the pinch gesture? And what you can see in this example on the left is that while users touch down relatively close to the target at the beginning, the further they pinch out, the further the target moves away from the actual zooming point. So the offset increases during the pinch gesture. And this is totally different with the indirect techniques. So here, the gaze zooming approach, here you can see this little circle that indicates the user's gaze, and it's actually floating around the target. And what happens is that while you're using the technique, during the pinch gesture, you can actually keep looking at the target and more or less refine your zooming target. And this way, you have a steady offset during the pinch gesture instead of an increasing offset as with direct touch. Okay. Third, we looked at the spatial alignment. So how did users use the different modalities on the display. And we specifically wanted to explore 3 different questions. So first of all, how close was the user's visual attention to the non-dominant hand? And the non-dominant hand was used for touch interaction, so we could just take a look at the touch to gaze distance during the tasks. And then we wanted to know how close was the user's visual attention to the pen, and the pen indicates where the dominant hand was. And at last, we looked at the difference between the non-dominant hand and the dominant hand. So did users keep both of the hands relatively close to each other, or rather further apart? And looking at the pen to gaze distance, we found that users were significantly closer to the pen when they used the pen zooming approach. And this is explained by looking at the design of the technique. Because you zoom where the pen is, it makes sense to actually also look at this position much closer than with the other techniques. And we got a similar result when looking at the touch to gaze distance. Here we found that users were significantly closer to their touch positions when using the touch zooming technique. So during direct touch, users look at their touch positions. This again is based on the design of the technique. So in both of the results, we found that users were looking closer to the zooming point, which totally makes sense. At last, we looked at the touch to pen distance. So here, we found that with both of the indirect techniques, with the gaze zooming and the pen zooming approach, users were keeping both of the hands, so the pen and touch inputs, significantly further apart than when they used direct touch input. And this is because of the indirect input. As touches are now indirect, users can put the hands anywhere on the screen, which allows for a more relaxed finger placement. And because of this relaxed finger placement, this also indicates that users avoid the issue of interference between both of the hands. With direct pen and touch, it's not really possible to use both of the hands in the same space because they spatially interfere. However, when you use direct pen input in combination with indirect touch, such as in the gaze zooming approach, it is possible to interact in the same virtual space. Okay, so I want to give a quick summary on the user study. What we did is we compared 3 different approaches of zooming on a pen and touch display. And in case of performance, we looked at the times and we found that the users are actually quite similar across the different techniques and tasks. Only the pen zooming technique was a little bit slower in the sequence task. We then looked at the zooming offset, so how close are users to the ideal zooming point? And with both of the indirect techniques, with gaze zooming and pen zooming, users were actually much closer to the point. So this indicates that users can be more accurate during zooming operations. We then looked at how the user's visual attention was aligned on the screen, and we found that it totally corresponds to the zooming point. So with direct touch, users look much closer to the touch positions. With the pen zooming technique, users were looking closer to the pen, to the dominant hand. And this also in turn shows that using the gaze zooming technique, it is independent of where the hands are, because there we did not find any correspondence to either of the hands. And at last, we looked at the pen to touch distance, so how close was the non-dominant hand to the dominant hand. And we found that when using direct pen and touch, users were actually normally interacting in the same space, so relatively close to each other with both hands. And using the indirect techniques, however, gaze zooming or pen zooming, users were quite far apart. So they used the space they had on the screen to also avoid the problem of interference. So overall, what we showed with our research is that we can utilize indirect touch in one hand to support direct pen input in the dominant hand. And this forms a new way of bimanual input where parts of it is indirect and the other part is direct. And our study showed that to enable indirect touch, we can use the gaze and pen modalities as potential targets of the pinch to zoom actions. And this integrates well into this bimanual interaction context of pen and touch. And at last, I want to emphasize two benefits of this way, this bimanual input configuration. First of all, users can interact without the hands interfering, because one hand is indirect and the other is direct, and both of them do not overlap in the same virtual space. And second, what we found in our user study is that using the indirect zooming approaches, users were much closer to the ideal zooming point. Okay. So, yeah, thank you very much for your attention. I'm happy to answer questions.
Yves Guillard, Telecom Paris. I like your presentation. Nice work. I like it. It's very nice.
Thanks.
So, I very much enjoyed learning your gaze effect. I mean, the difference between the gaze control, the expansion point versus the hand versus the third condition. I think that's very useful. When we worked on this subject 10 years ago with Bourgeois, as you know, because you read the paper, we were curious about whether we should use, what should we use at the point of expansion. You know, of course, the difficult part in panning and zooming navigation is, of course, the zooming in phase. This is a difficult task, but of course, and so what you show clearly is that if you use the gaze point, the fixation point, then it works better. By the way, I'd like to talk to you because there should be ways to quantify your results. I mean, ways that you maybe have developed, but you didn't take. You didn't refer to them. It's a very nice result. I like it. Congratulations.
Thank you. Good question.
I was wondering, for example, how would the conclusions be if it was not single-handed zoom, but kind of two-handed zoom, in which you can modulate also the points, because that's also something different. Like you don't have the constraint of the single-hand opening of the two fingers.
Yeah, that's an interesting question. Of course, you can also, I mean, in how we designed the techniques, you can actually use both of the hands. So the index fingers or something to zoom in. But we totally focus on this pen and touch combination. But I think it also works well using that.
Thank you.
Yeah, good future work point.
Hi, Eric Stoltman, Indiana University. Very interesting work. Thank you. So one question is, you tried this on, I don't know if you tried these three different versions on three different types of applications, or if you actually tried them on the same. So one was you showed the medical, you showed the map. And if you believe, do you have any idea if different types of applications actually would lead to different types of results for you?
So in our study, we used this abstract multiscale pointing task. And I just wanted to motivate the techniques more, and that's why I had the maps application and the medical image application. But of course, it totally depends on the application as well. There might be an application where you do not want to use gaze because you might wander around with your gaze and then have some errors. So yeah. But I think for what we investigated, the zooming part, then the gaze position is actually really fit for this approach.
Just a quick question, Jeff Johnson. What if you didn't decide in advance which of these techniques you were going to use, but instead allowed it to be dynamic in the sense that if there was no pen down, then it was pinch. It was the placement zoom. And if the pen was down, then it was on the pen. And if the eye was in a different place than the pen, then it would be the eye. And so then the question would be, I would be really interested to know if that would prove to be too unpredictable for users. You see, or it might actually be intuitive. They might actually expect that.
That's a good question. I did do a little bit of work in this, so that when you would look at your touch, you can actually zoom where your touches are, and when you look kind of far away, you would zoom where your gaze is, because your visual attention lies on that point. And also with the other techniques. So, but these are more ways to integrate them in industrial application, I think. Like when you Photoshop, you could have different options as well to select between the different techniques and to enable or disable them. But allowing them all at the same time is a good question. I think it would be too much, but I haven't tried it out yet. So. But good thing of future work. Okay, thank you.